Hello everybody. Today we are going to do the chapter probability. The first topic of probability in class 12 is conditional probability. That is what we are going to discuss today. Now, conditional probability is like any other case of probability. We have to apply the same formula, number of favorable outcomes upon total number of outcomes. Just one change is there. There is a condition attached to the sample space here, and we have to modify the sample space according to the condition given over there. Then only we can proceed with the question. I'll consider a case of tossing of 3 coins. Now when you toss 3 coins, how many elements are there in sample space? 8. I'm going to write them for you. These are the 8 elements in the sample space. Okay. Now if somebody comes and asks you that what is the probability of getting 3 heads in the toss of a 3 coins? Probability of 3 heads we are talking about, right? That would be 1 upon 8. How so? Because there is just one case where we are getting 3 heads among a total of 8 outcomes. Same favorable upon total thing we did and we got the answer, right? But if I make a slight change to this very question here, a slight change, I'll write the sample space again for you for better understanding. Now that slight changes, we still have to find probability of 3 heads. With one caveat that there has to be when there is at least one head. In the sample space. Now, if you follow this condition, then this particular element of the sample space is not acceptable to us, right? And if we ignore this, then how many elements are left with us? 7. Of those 7 elements, if you try to find out how many are having 3 heads in it, there is just one, right? So in this case, the probability would remain 1 upon 7. Now what we have done here is, according to the given condition, we modified the sample space. There was one element in the sample space which was not satisfying the given condition, so we strike it off. And from the remaining, we counted them, there were 7 elements. We saw how many were satisfying the required probability of 3 heads. 1, so probability is 1 upon 7. The same thing can be done using identity as well. I'm going to write the sample space again for you. Now, what's the identity? Let me write the identity for you first of all. Identity goes like this. Prob of A slash B is prob of A intersection B. Just a sec. Prob of A slash B would be prob of A intersection B upon prob of B. That's the formula. Now what does this prob of A slash B stands for? This is prob of A, prob of event A with condition B. As in this case, if you try to find out what is A, we are trying to find out probability of 3 heads, so that is our A. Now what is B here? The condition. Condition, it demands you to have at least one head, right? Now the A thing, I'm going to underline those satisfying this condition A, and there is just one here. Now remember, when you're applying the identity, you don't have to modify the sample space. The entire sample space, all 8 elements here would be considered. Like in the previous case where we modified the sample space while using the identity, we don't modify the sample space. So there is one element satisfying A among a total of 8, right? Now we'll go and see B. How many are there satisfying B? For B, I'm going to circle elements for you. And as I can find, except this triple T, everything satisfies it. What basically we want is at least one head. So we have a head here as well as here. In all these cases, we have at least one head, right? Except the last one. So let's ignore that. Now, when you go to apply this formula, first you need A intersection B. A as well as B, dash as well as circle, and there is just one element where there was a dash as well as the circle, right? So probability of A intersection B here in this case would be 1 upon 8 divided by probability of B that is circle. How many circles we see there? 7. Count them here. 1, 2, 3, 4, 5, 6 and 7 elements are there in B. So prob of B would be what? 7 upon 8. So the required probability is 1 upon 7. So we have both the choices open with us. We can modify the sample space as well as we can use the formula. But normally we go with the formula because writing the sample space is not easy always. Now I'm gonna do a few questions for simplicity, for your better understanding. Now let's begin with this question. This is question number 12 of the first exercise of your chapter probability in NCERT. Now this question says if there are two childs in the family, they can be boys or girls, whatever they may be. What is the probability that both the children are girls? In the first case, it is given that the youngest child is a girl. Now I'll write the sample space for you again. You can have both the child in the family as boys. The first child is a boy, second child is a girl. Or first child is a girl, second child is a boy. Or maybe both are girls, right? Now, what does it want in the first case? It wants you to find out probability of both girls, right? This is what they want. Both are girls. What is given here in this case? That youngest child is a girl. Now, if you go for A, the probability, the event was probability we are looking for. This wants both girls, right? Now, if you want B, it says the youngest child, the child born at the second place is a girl. Now, there are two cases here satisfying this condition, right? One is BG and another is GG, right? So when you go to apply this A slash B here, it would be prob of A intersection B upon prob of B, right? Now A intersection B, common among the two. I find just one element common among the two, right? So probability for that would be 1 upon 4. Remember, there were 4 elements in the sample space, and while using the formula, we consider the entire sample space as a whole, right? And that's the answer. Now, probability of B, if we are talking about, there are 2 elements here among a total of 4. So probability for that part would be 2 upon 4. Finally, the result is 1 upon 2. Now, let's consider the second part. Here in this case, again we are looking for probability of both girls. And what is given here? At least one girl. Right? Now, the A here is this, and if you talk of B, at least one girl. So here we have a girl, here we have a girl, and here too we have girls, right? So these are the 3 conditions being satisfied by B. Now, if we are looking for prob of A slash B, that's A intersection B upon prob of B. Now, how many elements are common there? Just 1. So, A intersection B probability would be 1 upon 4. And B, there are 3 elements. Hence, 3 upon 4. Final result is 1 upon 3. Now I will consider one more question for better understanding here. Now let's read this question. It's quite a bit lengthy question, so I would again suggest you to pause the video, read the question carefully, and then see the solution for better understanding. Now, we have a total of 1400 elements, 1400 questions here. So obviously we cannot write individually all those elements, the sample space here. So I'm just going to write the data for you. Now, what is given here? There are 300 easy, true, false questions, right? Then there are 200 difficult, true, false questions. And then there are 500 easy multiple choice questions. And then there are 400 difficult multiple choice questions, right? So a total of 1400 questions are given to us. We are looking for probability of an easy question. So what is A here? An easy question, right? And what is given here is a multiple choice question. What is B here? An MCQ. Now let's try to find out A/B here, which is again prob of A intersection B upon prob of B. Now A intersection B, that is we are looking for easy as well as multiple choice, and we have 500 easy multiple choice questions among a total of 1400. So probability of A intersection B would be 500 upon 1400. Now coming to B, MCQ. How many MCQs are there? A total of 500 plus 400, 900 out of 1400. So the probability for the desired part is 5 upon 9. I hope you got this topic. Don't forget to subscribe this channel. Thanks for watching.